Let's solve systems using elimination. Teacher, what's your solution of the system of equations? Student, nothing. I used elimination and got rid of the whole thing. Well, we don't want to really get rid of the whole thing, but elimination is in the title, so we are going to be eliminating something along the way. In our agenda, we're going to use algebra and elimination to solve a system of equations. We'll do 4 problems together. Let's get ready. Be sure to grab your paper, pencil, and calculator, and make sure you take notes on the last slide. With solving with elimination, we want to eliminate one of the variables by making it add to 0. We want to be sure to put both equations in standard form. Remember, that looks like ax plus by equals c. Here's our first example, and if you notice, they both are in standard form. Ax plus by equals c. So let me erase that, and we'll set this up. All right, I have my 2 equations. I'm going to draw my line underneath, and I want to add down. Some places, some people will allow you to subtract down, but I think we have more difficulty with subtracting, so I like to keep it addition. So if I add my x's straight down the column, I have 3x minus 10x, which is a negative 7x. If I add my y's, I have negative 4y plus 4y, which adds to 0, which is what we're trying to do, and therefore that variable is eliminated. And then if I add my constants down, negative 5 plus 12 is 7. And now I have an equation with just one variable, just x, so I can continue to solve. I'm going to divide both sides by negative 7, and I get x to be negative 1. Remember, we're not finished. We need to find the y value. You can plug that back into either equation. I'm going to go into the first equation. So I have 3, plug in my x as negative 1, minus 4y equals negative 5. So negative 3 minus 4y equals negative 5. I'm going to add 3 to both sides. Negative 4y equals negative 2. Be careful, don't just guess that the answer's 2. Make sure you're dividing the correct way. I want to undo the y that's being multiplied by negative 4, so I'm going to divide by negative 4. And a negative divided by a negative is a positive, so I get 1/2. Put that together, and my answer is negative 1 and 1/2. That is my point that these 2 lines intersect at. There's my answer, negative 1, 1/2. So what if I were given 2 equations with 2 variables, and I just added straight down? X plus 3x is 4x, negative 4y plus 2y is 2y, and 5 plus 29 is 34. Well, I end up with a new equation. There's an x and a y in there. I didn't cancel anything. So you can't just add straight down if nothing adds to 0. Let's try this example. When I first look at it, they are both in standard form, which is good. If I were just to add straight down, nothing is going to go to 0. So I need to decide, do I want my x's to go to some form of 4, or do I want my y's to go to some form of 3? I'm going to go to 3. So if I already have a positive 3y, that means I need to get a negative 3y up here. So I'm going to multiply this first equation by 3, everything. So this becomes 3x minus 3y equals 3. Common mistake is to forget to multiply by that number. And then my other equation, negative 4x plus 3y equals 5. I kept that the same. And now I'm going to add down. And when I add down the first column, 3x plus negative 4x is a negative x. Negative 3y plus 3y is going to add to 0, and 3 plus 5 is going to be 8. We're not done yet. We still have this negative out there, so remember you can divide by negative 1, and x equals negative 8. I can plug that back into either of my equations. I'm going to go into my first equation because it doesn't have coefficients. So I'm going to plug in negative 8 for x, minus y equals 1. Now I'm solving for y, so I'm going to add 8 to both sides, and I get negative y equals 9. Again, divide by negative 1, and y equals negative 9. My final answer, when I put it together for a point, is negative 8, negative 9. There's my answer. Let's try this example. They're both in standard form. When I add down, nothing's going to cancel. We have a lot of coefficients, a 5, a 6, a 2, and a 3. So I could think about making this, the x's goes to 10 or the y's could go to 18. I think I'm going to stick with the 10. So I need to make one of them 10x and the other one negative 10x. So I'm going to multiply the first one by 2 to make it a positive 10. And I'm going to multiply the last one by negative 5 to make that a negative 10. So sometimes you're going to have to multiply both equations. Again, we're going to distribute it all the way through. So my new equation becomes 10x plus 12y equals negative 16. And my second equation becomes negative 10x minus 15y equals 25. Be careful right there. A negative times a negative is a positive. I'm going to add down, and 10x plus a negative 10x is 0. I have eliminated my x's. 12y plus a negative 15y is a negative 3y, and negative 16 plus 25 is 9. I'm going to divide by negative 3, and I get y to be negative 3. We can plug it into either equation. I decide to go in the second equation because the numbers are a little bit smaller. So I have 2x plus 3, plug in my negative 3y, 2x minus 9 equals negative 15, add the 9 over and I get 4, divide by 2, and x equals 2. Put that together, my point is 2, negative 3. Did you get that for an answer? There it is, 2, negative 3. And this is a little challenging. Try this one. And the answer is negative 3, negative 2. Did you get that? I'm going to show you what I did. I could do the first to 6 or the second to 20. I'm going to stick with my first. So I'm going to multiply the first equation by 3 and the second equation by negative 2. So I'm going to get 6x minus 15y equals 12. And I'm going to get negative 6x minus 8y equals 34. I'm going to add down. And when I do that, my x's are going to add to 0, so I've eliminated them. I have a negative 15 plus a negative 8, which is a negative 23y equals 46. The numbers are a little bit bigger, but just keep in mind what we're doing. We're trying to solve for this y, so I want to divide everything by negative 23, and y is going to be negative 2. Take that, I'm going to plug it into the first equation, and I get 2x minus 5, plug in my negative 2 equals 4, 2x plus 10, negative negative is a 10, and I'm going to subtract the 10 over to get negative 6, divide by 2, and x equals negative 3, and that does check with my answer. Let's make sure you get these in your notes. When you're solving using elimination, you want to get the variables to add to 0 so you can eliminate that variable. You might have to multiply one or both equations by a number, and then be sure to plug your answer back into either equation to solve for the other variable. Good job.